Welcome to this webinar about CMCD, the Common Media Client Data Standard. My name is Alexander Lishinsky. I'm the co-founder and CEO of GNL and will be your webinar host today. We seem to have hit a nerve as we received well over 200 registrations, which is amazing. I'm really happy about that. The main reason for this huge interest, I assume, are our 4 experts presenting today, and I'm extremely proud to have them here today. So we have Will Law, Igor Oreper, Tobias Drees, and Brandon Au. And I'm stopping the presentation here so that you can see them all in real life. So welcome everybody here. And as time is limited, we start right away. So I will just go ahead, start my screen share again, hand over to Will because he starts the first part. So let's share it again here. And I will hand over to Will.
So thank you, Alexander, and to GNL for putting together this webinar. It's really great to be able to talk about it to you all. So I'm just going to deliver a very quick intro as to what CMCD is. I know most of you have actually, or more than half of you have probably presented this before, but I think there are a number of people in the audience who can benefit from a very brief overview. So let's go next, please. So CMCD is basically a bridge between 2 different worlds. On the left, we have the world of players, where you see things in terms of playback sessions, right? A viewer joins, they play some media, it might rebuffer, and then they stop playback. But if you click, we'll see on the CDN side, we just see a bunch of requests for objects, right? We don't know how many people were involved in the session. We don't know if the player is rebuffering. In fact, we're pretty ignorant about what's happening on the other side of that connection. Next, please. So we are blind to the media characteristics. So from the CDN side, if you see this in a log line, segment 3246.m4s, we cannot answer these questions. And there's quite a few of them, Alexander. You can just click 5 or 6 times. So how long is this segment? 2 seconds or 6 seconds? Is it HLS or dash? They both use CMAF. Is the player at startup or is it at a steady state? What's the bit rate of this media that it's playing? Because the CDN doesn't read the manifest, right? It has no idea if it's a 4K file or an audio file. Is it video or is it audio? Is it a live stream or is it a VOD stream? I can't tell just by looking at the requests. Is the player healthy? Is it rebuffering? And if I deliver it in 2 seconds, am I doing a good job or a bad job? Now, if it's a 6-second segment and I deliver it in 2 seconds, that's a good job. 3 times faster than real time is enough for the player to keep its buffer nice and healthy. But if I deliver a 2-second segment in 2 seconds, or even in 3 seconds, that's going to degrade the player's buffer and performance is bad. But I can't tell because I don't know the duration of the media object. So that's the blindness on the CDNs. Now, on the player's side, the players also has some questions. So next. So why doesn't the CDN know that there's poor performance? How many times have you called up your CDN and said, my players are rebuffering in Zurich tonight, but the CDN says, well, I don't know, my servers look okay. And it's very hard to tell that there's a performance problem. How do you tie together your QoE metrics? You're getting metrics from Mark's Bit Moving Nice People at Work Conviva. And we see some questions in the Slido already about the interplay between CMCD and Conviva and QoE providers. So we're going to address that. But it's very hard to tie those with your CDN logs without a common join. And the CDN logs can hold the answers to why you might be having delivery problems. How do you consistently tell all your CDNs to prefetch the next media object? In other words, pull it to the edge so it's ready when the player needs it. It's one of the best things we can do to improve media performance, but there has not been, up until CMCD, a standard way to do that all CDNs will support. Next. And when you look at your CDN logs, you're going to see data in terms of hits, right? But when you see 23,000 hits, is that 10 views of your video, 10 sessions? Is it 100 or is it 10,000? So if you don't have your analytics solution, then how do you get any sort of idea how many people actually watched your content? Next. So there's a need for players and CDNs to exchange mutually beneficial information. And we don't have to invent anything radically new. Just click 3 times. So the player is already requesting media objects from the CDN. If you click. So we make a GET request. And on that, we can append some custom query args. Or if you click again, we can append some custom headers. So it's nothing fancier than that, right? Let's just go, next slide. So defining this was done by a group called the CTA. It's an international group, and within it, there's a project called the WAVE project, and you can see some of the companies here. So it's a formally issued specification, CTA 5004, and it's actually almost 3 years old, 2 to 3 years old at this point. So the spec's been out for a while. Next, please. So what do this information look like when it crosses the wire? There's 3 different ways it can come: as headers, as you can see at the top, as query args, which is basically the header information, but URL encoded. And there's a single reserved query arg, which is capital CMCD, that's reserved for CMCD, and also as a JSON object if you wanted it. And you'll notice if you click that on the headers, we shard the CMCD data across 4 headers. This is not because the request or the status is somehow going to a third-party system. It's simply because of HPACK and QPACK dictionaries for H2 and H3 delivery. If we put all the data in the same header all the time, it would start to explode our dictionary because it's constantly mutating. But information in the session header is relatively static over the whole playback session. So we can save some of that churn in the headers and keep the dictionary size a little smaller. Next slide. So what are some of the things you can do? We're going to talk about the next hour for things, but here's just the quick highlight summary. So next, you can count the number of sessions viewing your content in real time. This is if you don't have a QoE provider. You can do it just by looking at your CDN log data, which you're probably monitoring already. You can monitor the health of a player population in real time. So you see some of the charts over to the right. Those are actually generated entirely by just looking at CMCD data. Next. You can prefetch content to the edge. You can improve the performance of your media delivery by hinting to the CDN what's coming up, and it can pull it to the edge and have it ready and waiting when your player needs it. Next. You can do multi-CDN content steering. So there's HLS and Dash specs that have come up, but they give relatively lightweight information to the steering server, right? You report the bit rate that you're playing and also the source of your steering. Sorry, you report the measured throughput and the source, but that doesn't really tell the story. So what you can do is build a much richer content steering solution by gathering CMCD metrics in real time across all your CDNs and using that, which is giving you bitrate and buffer length information and rebuffer counts, and use that to steer your players more intelligently. You can preserve sessions through masked proxies. This is Apple Private Relay. It's intentionally obfuscating client IP for privacy. So if you want to identify your users, you want a standard way to know that this is one session and have it robust over the masked proxy. You can also build a QoE monitoring solution. Now, it's not going to be as fancy or as complete as what Bitmoving, Conviva, nice people at work and Mux are offering you, but it's going to be a baseline one that can give you a lot of the information that you need. Next. You can debug delivery problems, right? Because now you can tie your playback session to actual CDN servers that touched or served your content. And that's where the slowness can be. But otherwise, you're dealing with a black box and you have to call up and you've got 2 different data sets and 2 different support teams that are each pointing fingers at the other one. Next. You can analyze data to extract insight. That's the chart on the middle on the right, just looking at how does throughput vary by ISP? Because you're getting information from your CDN logs that your player just doesn't have, such as network AS information. Next. You can apply delivery optimizations within the CDN based on the media characteristics of the object. For example, if the player tells you that this segment's involved in startup, you might do something special within your CDN to get it to the player extra quick because you know that it needs it to build a healthy buffer at startup. But you're not going to do that for all the media segments. It would be too expensive. Next. So this slide is actually out of order. It should have been placed before what can you do? But in summary then, common media client data is a defined set of structured key value pairs that communicates mutually beneficial related information from a player to a CDN via one of custom headers, query args, or JSON object. You use one, you don't use all 3. And it's common because it's the same data structure across all players and across all CDNs. This is not a CDN-specific solution. This is an industry-wide solution. It's also free to use, and there's no royalties, and you can go download it at this URL. Next slide. This is just one slide showing you the keys that are sent. There's not a lot of them, right? If you compare it to what a full-blown QoE system's sending, which might be 100 different data points, there's very few. The goal was the low-hanging fruit. What's the minimum amount of information that can be transferred to give the greatest gain between player and CDN interaction? And I'm not going to describe all of them. Okay, it's important also to describe what I've said what CMCD is. It seems like the answer to everything. So let's also say what it's not, or what it's not yet, right? In Silicon Valley, we would say it's not all unicorns and ice cream cake, okay? So it is not yet a full replacement for a full QoE analytics client. I think if Bitmoving wanted to turn it into one, Bitmoving could, but that's not Bitmoving's business, right? So it is not there, and it cannot replace the full depth of information that a QoE client is going to collect for you. It's collecting, as I said, those 17 keys. That's it. It's not a generic monitoring system from its start, okay? CMCD will not allow you to replace your entire QoE vendor. It was designed to collect segmented media delivery. That's HTTP, not from progressive download or WebRTC or non-media applications such as game delivery. It's focused on adaptive segmented streaming. It doesn't leak privacy, right? We tried really hard to make sure that there's nothing persistent that's communicated via CMCD between sessions. So session IDs are random, buffer lengths and throughputs are fuzzed. CMCD data cannot be used to identify the user. It is not a proprietary standard, as I mentioned. It's free and available with no royalties. It is not yet available on all players. We're certainly trying to make it available on all players. And everyone says, well, is it instantly available everywhere? No, it used to be available on just one, Dash.js. And as you're going to see later, it's available on a whole host of players today. And it's not a standard just for CDNs. There's three stakeholders who benefit from CMCD. The content distributors, that's the people distributing the content. The CDNs, the people responsible for delivering the quality of service. And then the end users, who can, because this content distributed and CDNs are doing a better job, ultimately they should get improved QoE when they play back media. Now, everything you hear about today is what's called the first version of CMCD, the one made back in September 2020. At CTA Wave Project right now, we're in the process of developing version 2 of the spec. And I co-chair the group along with Paul Cabernetti at Google. So just some hints as to what's happening there. So our goals are to fix bugs and tighten definitions from V1 based on deployment experience over the last 2 years. We want to add some new keys to improve the reporting. And we also want to add new features, basically to improve the utility of CMCD. We began the work September last year. We expect it to take probably the remainder of this year to complete. The issues are all public. You can go and view them on that link in GitHub. So just a teaser as to some of the new keys that we've added already. We've added target buffer length. This is very useful for monitoring if you've got 10,000 players and they're spread across TVs and set-top boxes and mobile devices. And if you see that for some players, a buffer length of 8 seconds is high buffer because they're only expecting a 6-second buffer. But for other players who are going for a 60-second buffer, 8 seconds is really bad. So you need this target buffer length to be able to scale and add meaning to the buffer length that's actually reported. Top encoded bitrate, this was feedback from Apple about information that's actually communicated in the master playlist that is not sufficient to describe the media-specific encoded bit rates that we had previously. So we add some keys to describe that. Video start time. This is a big metric. We decided to just report it explicitly versus infer it by several tricks that we have. And also aggregate encoded bit trick actually matches tab. So we're not done adding new keys. We're going to add some more keys on this. Next slide. And we're also going to add something that's quite new. And this animation, I couldn't get it to work in Google Slides so well, but you get the idea. The notion that under CMCD v2, you'll be able to report metrics to third-party destinations. So much like your QoE clients do where they hit a beacon and they report it, you'll be able to do that with CMCD in addition to or in place of, at your discretion, whether you report on every media segment. So we see the red arrows represent the player sending CMCD data with every segment it requests, and the blue ones are sending it at a time-based interval. So I might say every 20 seconds or 30 seconds, I'm going to report aggregate metrics, right? They're decoupled from the actual media connection. So I report what's my buffer, my status, and what bitrate am I playing. And if I have a buffer-specific event, I can report that explicitly. So this is still being designed. If you like this idea, jump on the issue and give it a +1. If you don't like it, explain why and explain how we might be able to do it better. Next slide. Right, and that's it for me. I will step off and we'll go back to Alexander.
Great, thanks a lot, Will. So market penetration. So we are looking into which players in the market, which CDNs, who is using it, who is supporting it. And so let me check here on the right screen. So we start with the players. So we have a pretty broad support. We have the commercial players here, listing Bitmovin, Theo player, the Akamai player, the Radiant Media player. We have very important some of the native SDKs and setups and architectures that need to support playback in the native devices and native applications. The most important one definitely being Exoplayer, so that you can use Exoplayer and are sure that you can use CMCD in an Exoplayer-based application, but also Roku. And there is another player, the RDP AMP, which is also a commercial native setup that supports CMCD. The open source players, HLS, JS, Dash, JS, Video.js, and Shaka, they also support CMCD. The big question is, what is about the Apple ecosystem? There have been some on-site discussions in October 2023, and this is a slide where you see that Apple knows about CMCD, they are aware of that, and we are all keen on observing what happens at this front over the next couple of months, perhaps. If you want to check if the player that you're using is doing a proper implementation of the CMCD standard, you can use a very helpful application by Qualabs, which is the CMCD analyzer. So it checks if the players really are compliant with the standard, and this is a very nice way to be sure that all the players have implemented the standard in the right way. So this is also a GitHub project that you can look at under the URL that is seen on this slide here. On the CDN side, there are different ways in which CDNs can support CMCD. So the least common denominator is just forwarding, just passing through the information that they get from the client. And as long as it's using query string parameters, there is no reason why any CDN should not forward this information, even if they are not actively supporting it in any way. Because usually if a CDN gets a request with the query string parameters, even if they don't know what this is about, they can still just forward them into the logs that you receive, and then you can work with this information. The next step is CDNs that are actively supporting or knowing about CMCD, and this usually starts with providing some reports on that, so that you have some specific CMCD-based reports from the CDN itself. And the next step is that CDNs actually do something with the information that they receive about that. And at the forefront, for sure, is Akamai, so that they can do some prefetching or other optimizations because they get information from the client that they otherwise wouldn't have known about. So those are the ones here that we have listed that are most elaborate about the CMCD support. So, but in generally, you should expect every CDN to support at least the query string parameter version of that. On the content provider side, there is no official list about this, but companies who are observed using CMCD in the wild or are actually asking for it in job descriptions are Paramount Pictures, MTV, CNN, and the whole Warner Brothers world, NBC Universal, Disney, and Vimeo. So you are in good company if you are using this standard for your content delivery. On the analytics platform side, we have TouchStream today here, so there's no surprise that they support CMCD. DataZoom is very active in the definition of the standard itself. Hydraulics has a couple of integrations specifically for CMCD. Bitmovin is also talking about this today, and Max also is as a player in this area here. So there is a good mixture of support for a standard that is not that old in terms of standards. So it's good to see that there is a lot of progress. So I only can encourage you to look into using CMCD in your specific environment. Okay, I hand over to Igor now for a client-side analytics and player part.
Great. Thanks, Alexander. Welcome, everyone, and big thanks to GNL for hosting this webinar. It's really timely. Seeing and hearing a lot of interest in CMCD in the field. Alexander went through a number of content providers, players, analytics solutions, and also CDNs that support it, and that list is growing pretty quickly. Next slide, please. Okay, so I want to talk a little bit more about player support, but also QoE analytics support. So in the player for CMCD, why does it make sense to do this in the player? Well, it gives you a chance to troubleshoot errors and find root causes much faster. I think folks who have been in the streaming industry for a while and they understand and have kind of gone through the technical operational issues with the finger pointing, as Will talked about. A lot of times the client side folks will say, well, if there are problems, it's a problem with the CDN, it's some upstream thing, right? The player is doing everything it needs to do. And then if you talk to the server side and CDN folks, they say, well, the player is not behaving properly and it's not doing what it's supposed to do. And so I think CMCD really does help to resolve this issue because you can now troubleshoot these errors really quickly. And we have one anecdote from the field that I heard, which is a DNS issue that was found in a CDN node actually manifested itself as buffering in the player. And that's a really hard thing to figure out and resolve. And so because you can now tie sessions between the player and the CDN, you can get to the bottom of those problems really quickly. Another thing is workflow optimizations proactively. So now that you can correlate player and CDN logs using this common session ID as well as content IDs, you can also improve behaviors, right? So you can correlate, for example, round trip time for delivery of a particular segment, audio video segment, back to buffering. And so that was something that there's no way to do that before CMCD. And then another really interesting use case is prefetching content. So now you can prefetch content to improve the user experience because the player can communicate to the CDN which audio and video segments are upcoming so that those which are most likely to get played or to be requested by the client next can be pre-positioned at the edge before the player tries to download them. Next. So just an illustration of prefetching. On the right, you have client devices. Client devices are requesting segments. And so the end segment is the current segment that the client device needs to request, but it can also send the CMCD next origin request data element, which says, okay, well, here's the next segment that's upcoming. And the CDN can already start pulling that next segment while it's delivering segment N. And so once segment N is delivered, then N+1, and then N+1 after that it's already there at the edge, waiting for the client to ask for it. So really great capability. Yep, next, thank you. So player CMCD integration. So I wanted to share a little bit about how the Bitmovent player can enable CMCD. This is all configuration, so the player already supports it. As you saw, other players also support it as well, and the configs are similarly easy. But really all we're doing here is we're creating the CMCD config object. We're seeding it with session ID. And then when we instantiate the player, then we also provide that session ID, and by the way, also content ID. And so you can track from the player informs the CDN which CMCD session is being used, and also the content ID. And so then you load the player source, and now you're channeling the CMCD data along with the requests. Next. So analytics, I think this is a really interesting one because there are quite a few quality of experience analytics solutions, right? The client-side solutions that allow you to really measure a number of things, right? Audience engagement, who's watching and what are they watching, how long are they watching? Also the quality of experience metrics, things like buffering and startup time and view time. And as Will said, there's quite a lot of data that you can get from the client to give you an understanding of how the client is performing. But what's really interesting with CMCD is now we have the ability to turbocharge your technical operations and customer support teams by tagging these sessions with IDs. Well, now you can trace it all the way back to the CDN. And so you can investigate performance of individual sessions and correlate that back to the client-side quality of experience metrics. So you can really understand where in your video supply chain the problems may be manifesting. So that's one use case. Another use case is you can see how the viewer experience is actually influenced by CDN performance. And so I talked about an example of that before, but imagine if you can now overlay round trip time, which you get from information from the CDN with rebuffering information that you get from the client, right? So now you have a lot more information. You can do all of your breakdowns based on really all of the CMCD key value pairs and overlay charts that make sense to give you a little bit more information about how the server side performance is impacting the client side. Next. So now I hand over to Tobias.
Thank you, Igor. And hello, everybody. I'd like to talk a little bit about players who do not support CMCD and what we can do about it. So the next slide, please. Yeah, thank you. As you've already seen, there are several players integrated with CMCD. But as always, there are still players around or devices. This is just a few examples here. Apple Media Player, non-media source extension, connected devices, or players around the HBBTV landscape that do not support CMCD data. So, but what does that mean? So are you not allowed to play with the cool CMCD kits if you have these players in your portfolio? Well, in short, no, it doesn't. Because, and please, the next slide. Anders Nassmann from Akamai had a very, very good idea here. Because in HTTP streaming, as you all know, the player is not requesting the media objects directly. The first request always goes to a manifest or a text file in which the player will find the information, what to play and where he finds the media objects to play back. And after that, he's requesting, in case of HLS, for instance, the next manifest, and after that, the media object. So this sequential, we can use that to introduce a proxy between the player and the server at that point, and read out the appropriate data and inject them, the CMCD, in the manifest, so that with the next request, the player will use this query parameter that we attach here in the manifest to provide us with these information. This is working with HLS and Dash, and so we can help you here. Our setup now is set up, as you can see here. It's just a simple origin hosting a live stream. And after the live stream, there's a simple Akamai delivery configuration. And if the player connects to this Akamai configuration and it doesn't see any CMCD data attached to the request, it will route these requests to a proxy or edge worker in this case, which is running some JavaScript and which does what we want. So I set it up like this, and let's quickly look into how this is working or what the code does. Next slide, please. So we are looking at an HLS manifest here. That's a master manifest where you can see 2 video renditions and audio renditions on top. And we don't see any CMCD data here. So what we can do, we can add some. Next, please. So the first one, of course, we add the CMCD data. So next, please, you can click through it now. So for instance, we in the manifest, we have the bandwidth being written down for us. So we take it and we add it to the CMCD data. Next, please. So the next request will be a medias or a manifest request on the media MTU8. So we know that the object type is a manifest, so we add that. Please go ahead. We see from the manifest that this, of course, is HLS, so we can add the streaming format. And the next one, we don't see a session ID, which we can add also. So we create a keyword and add it to this rendition as well. Next, please. So additionally, we see that the top bit rate in this manifest is the 2766 kilobits per second. So we can add this information as well. Next, please. So now we add these information to all of the tracks here in this manifest, and we URL encode it. Next, please. And we're good to go. So, and the next request is going to the actual playlist, media playlist file. Next slide, please. So the first thing we do is we can inherit all the information that we just got from the first request and put it in here as well. But we do have some additional information here that we can extract here. So next, please. So for instance, the video type, we know this is a request for a video segment, so you can add the appropriate object type. We know we don't see any X endless tag in this manifest, so we add the live streaming type. And we do see for instance, the duration of the segment, so we can add this information as well. And additionally, next one, we do see that the next object here in the playlist is the next object, and we can refer to the previous request, the next object request, which will help the CDN to to do something like prefetching. So next, please. So we do the same here, add this content to all these segments here, and URL encoded as well. And so now I did set up 2 configurations. One configuration which just simply deliver a stream through an Akamai configuration and does simply nothing, and another one which does exactly this. It's routing requests that do not carry CMCD information to a network code. So next slide, please. What you should see is a player. In this case, a Video.js player on a Windows machine. What you should see, so the player is requesting the stream, the very same stream from the first configuration, and you will see on the right side that the CMCD information is missing. And if I just change the host name to the configurations that are set up for this, you can immediately see by requesting the very same stream that the information is being added to the request, to every request, yeah, we are good to go here. So again, we are able to inject data, not all of it, like an integrated player would do, but we will have information that's helpful for the CDN, for instance, for the prefetching feature, or but also for us, if you have a look at the session ID, which is extremely helpful, I guess, if it comes to log analysis, because it boils down the thousands of requests from a single session into one single session ID. And that's it from my side. Thank you.
Great, thanks, Tobias. So sorry for the technical issue here with the demo screen, but I think Tobias explained what we should have seen. So I hand over again to Will for a look on the CDN side.
Thank you. Next slide, please. So there's just 2 slides on, what should a CDN be doing under the covers? And really, the first job is do no harm. The CDN job is to collect this information from the players and give it back to the content distributor. So in step 1, you need to add in some access control allow headers, right? Because JavaScript-based players or players subject to CORS restrictions won't be able to send custom headers unless you explicitly allow it. So you have to make sure that in your response, in your CDN, that you are authorizing the 4 CMCD headers that players might want to use. Secondly, you've got to ensure that the CMCD query args are excluded from the cache keys. And every CDN is a different way of doing this, so you've just got to look at their configuration settings. But because the CMCD data will be changing all the time, it can blow up the cache if you allow the cache key, if you allow the CMCD query arg to be part of the cache key. And most CDNs will let you just strip out the CMCD query arg, but allow other query args to be part of your cache key because that may be important. So check your CDN for that. Number 3, you've got to collect the data because it can arrive in 2 different ways, from query args or from headers. Now, query args usually flow through to the logs, but headers do not. We do not, I don't think any CDN by default will log headers that are received. So your CDN has to be clever. It has to understand CMCD. And, well, it's not really clever because it's not complex, right? But it's got to look in 2 different places, collect the data, and then join it. So step 4 is join it with your CDN server-side log. So at Akamai, we have a custom field, and we stick our CMCD data inside there. And then number 5, whatever your CDN's mechanism is for giving you real-time data, it's got to make sure that that CMCD is part of the data. At Akamai, it's called data stream, and you can go check a checkbox to say, add my CMCD data to it. And if you wanted to, you don't have to get any CDN logs. You can just use that to collect your CMCD data. But mostly, there's a bunch of useful stuff in the CDN logs as well. So it's nice to get both at the same time. Next slide. And then the other thing the CDN should do beyond passing it through is try to improve its own performance of its delivery network. And the obvious one here, and Igor has already spoken about this. Next slide. Click. So I'm not going to go into the depths of it, is prefetching. But just to give you some real numbers, so I have a little workflow here and you can look at it. But the difference between prefetching the segment and not prefetching for some real world RTTs of like 20 milliseconds away from the edge and your final 2-tier distribution system, the final one is 50 milliseconds from the origin. You're looking at the segment arriving in 20 milliseconds instead of 95 milliseconds. And you may say, Will, 75 milliseconds, is it really that useful? And, you know, for players that are well connected and you've got a 3,000 or 10,000 millisecond buffer, yeah, 75 milliseconds doesn't matter. But for rebuffer rates now, for most top line distribution, you're 99.4, 99.6% buffer free. So we're really trying to get the 0.4, 0.6% of sessions that have rebuffering to reduce. And for that, yes, we do need to start worrying about 75 milliseconds because that can be the difference between getting the segment in time and not getting. So it's not the mainstream. We're looking at optimizing the edges now, both literally in terms of edge delivery and figuratively in terms of the bell curve of well-connected and poorly connected clients. So it's just one step down the road of trying to improve overall QoE performance. That's the end of my slides. Back to Alexander.
Yeah, great. Thanks a lot. So now we switch over to the actual monitoring. Brandon, it's your turn.
Great. Thanks very much. Okay, next slide. Okay, so yeah, we've heard a fantastic amount about how to actually create it and everything about it, but of course, you've got to use this data. Now, the great thing about CMCD data is it's very flexible, mainly because it's raw data, and therefore you have that raw data, and you're able to ask questions of the data that you typically aren't able to with QoE audience tools. But it's also more, in some ways, more and less, as Will's pointed out, than the audience tool. So CMCD actually leans more towards the troubleshooting side. So, you know, the audience is great stuff. It tells you what problems, tells you everything else that's going on in the players. But when there is a problem, you need to be able to find that problem and troubleshoot it. And that's what CMCD is really good at, because it is at the CDN level with the player data. It's not just session based that you can look at. You can aggregate in many different dimensions. And so whilst the session stuff is fantastic, and particularly if you've got a player that connects the session IDs together, you can actually then troubleshoot individual sessions. But you can also observe different issues with this data, and they geo-specific issues and ASN specific issues, specific CDN edge nodes. And these are all different things that require you to look at the data and analyze it in different dimensions and aggregate in different ways. So that's a really useful thing. And as the others have mentioned as well, this is a great input into content steering. So that will again further improve QoE by actually pointing you towards the most appropriate CDN edge node in your exact location. Okay, next slide. So there is a problem with this, though. CMCD uses CDN logs, and this is log analytics, and that is a lot of data. It's a tsunami of data. If you're a big player, this is a huge volume of data. And you need to actually understand that data. So it's not just, do averages and adding stuff up. You actually need to understand how a CDN works, how a player works, and actually make intelligent decisions on how to actually utilize that data. Next slide. And so, I just want to touch on the scale. I did some very quick estimates on the right-hand side there. So a CDN log line is approximately 600 bytes. And if you've got 2-second fragments in Dash, that's 30 requests per minute. And that's actually 17K per minute for a viewer. Now, then here's the numbers of the viewers added up. And you see, if you had got a large event and you've got 1 million viewers, the raw data for that is over a, what's that thing? Petabyte. So, it's a lot of data per hour. So you need to be able to ingest that. So you've got to have a really good log ingest pipeline that can cope with that sort of volume and is affordable as well. So this stuff's not cheap if you're doing huge volumes. Of course, there's obviously some tools at the CDNs, which sampling is the key one. Basically, typically people sample sort of 25% because you get a good, that's a pretty good 20-25% gives you a good idea of what's going on. But the problem with sampling is, of course, it depends on what type of sampling you do. Typically, people sample on, is it a 200, i.e. good, and is it a cache hit? So we sample out most of that. The problem is that skews the CMCD metrics, because that sort of says your CMCD data, when you're looking at it now, presents a worse situation than is real. So actually, we were discussing this on the preparation with the panel, one of our sessions, and actually Will sort of said, well, you could actually have two outputs. You could have one that's just CMCD only, and just so limit the number of metrics you get out to just those half a dozen metrics, and actually have an unsampled version just for CMCD and a sampled version for the entire log line. Next slide. So then you want to sort of summarize data. So then that's, again, the idea of having this raw data is you can actually summarize it. You can look for different things, have an objective in mind. And one of the examples that we've been looking at a lot is finding the trouble spots between the CDN and the ASN. So ignoring the session, just looking more at an aggregate level, but looking, and this little bit of data here is, summarized by the actual channel, by the CDN edge location, and by the client ASN. And then we're getting all the metrics associated with that, and that really helps identify where the problem spots are from a geographic, from a CDN, and from an ASN perspective. And seriously, all the stuff that we've done, it's between the CDN and the ASN. That's where you've really got to spend a lot of time focusing to help improve your QoE. Next slide. And so, we've done some funky layouts of that, and looking at where your data is delivered, and we also collect both the kind of network KPIs, what is the cache width, whatever, the throughput, the response time, all of that, and actually collect it together with the CMCD statics. So you can actually start to see things like the impact of slow links on buffer starvation, which is effectively buffer starvation is going to be buffering. So you can start to see these different relationships and where they are happening more or less, or what are the root causes of the problem, and these type of summarizations and visualizations can help you do that. Next slide. Okay, so you know, when you are visualizing data, you've got to think, what are you trying to achieve? And the people that we've been working with have always got a few different scenarios in mind. Obviously, you still want to do your standard QoE and get it from the CMCD perspective, but root cause is the other big one. And that's what I was showing in the previous slide. That's a really interesting thing to do. And another project that we did at the SVTA was distributed tracing. And actually, for distributed tracing, we leveraged the session ID of CMCD. So we kind of like piggybacked on CMCD to create a distributed tracing approach that has a session ID that goes all the way through it. So therefore, again, it's another deeper troubleshooting tool. And then as Igor has pointed out, and there's another one of the audience tools as well, they were already added in the linkage directly of the audience QoE tool with the CMCD thing. So being able to join those two worlds together is giving you a great benefit into fully understanding what are the problems and what are the root causes of the problems. Next slide, please. Okay, so there's a couple of issues with data, and one I've just sort of mentioned before is that with the sampling, that you typically sample down to 20 to 25% of good data, and then you say, but I want to keep all errors, so anything that's non-200 or cache misses or whatever. Now that gives you a slightly skewed result, and particularly when you desample that data, you could actually be overstating things and not getting the right thing. So as I said, the great idea that Will came up with was actually take two feeds and make sure that you're balancing those two things out. Have a second feed that's just CMCD and not sampled. And then again, as we've also touched on, the biggest hindrance, although you know we've got Tobias's great solution there of the edge worker, but the biggest problem is actually the how much of the player implementation is out there, and we've got a couple of our big customers in the US, and we see that they've currently still only got 20 to 25% of the players CMCD enabled, and obviously, you know, Apple is the big elephant in the room there. Thanks. Next slide. Yeah, and so, right, okay, so we've built some of these larger implementations, and here's a couple of our simple lessons learned. Scaling, it's much harder than you think to scale this sort of data ingest. What we did is we actually built some load testing tools, and then we thought we had it right, but actually we still didn't. So my suggestion is, if you're going to build something like this, build a load testing tool and make sure it can generate at least double the amount of traffic you expect, because that's the only way you're going to tease out the bottlenecks in your log analytics pipeline. Costs, it's just so expensive to do if you want to do it real time. So you need to, you know, create a good cost calculator, really measure the costs. We actually ended up finding, because we used a lot of cloud services initially, we actually found that, you know, you try to use the calculators given to you by the cloud services, and it misses a whole bunch of things that you don't think of, and really, you know, you really need to build it for real and actually get real data, and empirical data is your friend here, and then multiply that up rather than relying on the cloud provided ones, because you'll miss stupid things very easily. The decision on how near real time you need it. Everyone, of course, says you need this super real time. You know, for a lot of things you do, it's really great, but there is also, you know, we've had some discussions with some very big players, and they say, actually look, like we've still got our QoE tools that gives us a good idea how well things are going. And we're quite happy with half an hour behind, because that actually allows us to retrospectively look at stuff, because we looked at the cost of doing it near real time and it was just too much. So, you know, half an hour behind, you know, can be, but, you know, you're not going to be able to solve the same issues that way. So there is a decision there. What is it, you know, and then of course sampling gives you ideas. So you have to just sort of balance the cost benefit things and make sure you're getting the right ROI on your thing. And of course, picking the right KPIs, even if you pull all the KPIs out, you know, when you actually summarize that data up, you know, again, you know, your log ingest pipeline, it's expensive to do it. So make sure you're just picking the KPIs that actually matter, and that are solving the real problems. And I'm a big fan these days of creating a hypothesis, test it, and make sure it is solving the problems. Next slide. And yeah, that's what I mean. Start with a simple model, create a hypothesis. What are you trying to solve? Make sure you collect the right KPIs and measure them. What granularity, what frequency? Have a test plan. That's a great way to start. And you can do a simple version of this and just do it in AWS S3 or Google ECS and use something like Athena or BigQuery to try and prove out your ideas. So it's always a really good place to start. Next slide. And of course, in a conclusion, there's so much here. Hopefully, you've enjoyed what you've heard from everybody. As I say, create hypothesis, start solving these problems, start looking at stuff. But there's also a couple of groups. Talked about the CTA way, but also there is, which is fantastic, but there's also the SVTA in the QoE group. We are really exploring this year is the year we really double down on CMCD, and we've got a really great bunch of people working on that. There's also the SVTA University CMCD course. I would encourage you to look at that. And then collaborate with some groups, some people, Qualabs, as Alexander mentioned, they built the CMCD validator tool. They also run summer camps. I think they actually developed the course as well. So there's some really interesting people out there that are doing stuff. So get involved. That's my message to you. Okay.
Great. Yeah, then thanks a lot, Brandon. So I think we can stop the share now here because we're at the end of the presentation part. So I encourage you to all turn on your video again and we can come to the Q&A session. So at GNL, we are always happy to actually use all the fantastic tools that you provide and integrate them into solutions that solve these problems for customers. We have a couple of questions. So thanks for everybody who asked questions in the Slido part here. So I suggest that we just go one by one from the top down. So the first question is, how does CMCD overlap with client analytics tools like Conviva? We already touched on that, but perhaps Igor, you can just recap your major point here.
Yeah, I mean, I think the major point is one enriches the other, right? So you can enrich the client-side analytics data with data from the CDN, and likewise, you can send client-side data to the CDN and generate reports like Will showed you. You'll get the richest data from the client, but to have the CDN logs as well, it gives you a lot more insight into what may be causing a problem or a great viewer experience for you, right? So you can continue to optimize having a full view of your video supply chain.
Yeah, and we also talk with customers who have the problem that sometimes they control the player, so they could use a client analytics tool, but they don't get the logs because the logs go through a CDN from a service that they just have the content from, and the other way around. So both cases might be corner cases where it's beneficial to have both sides then.
And the other big differentiator is Conviva can't do prefetching. It can't in real time help your CDN improve performance. It's all retroactive, right? Whereas CMCD provides an immediate and real time link between the two.
Yeah, good point, Will.
Yeah, thank you. Thank you. Another question, the big elephant is the Apple ecosystem. So support for CMCD. We have seen that they are aware of the problem. Is there anything we can share about what will happen, or if there will happen something? They are very seclusive usually. So any comment on that?
No comment. Apple don't release future product roadmap. We all know that. But there's been a lot of good outreach, and the Apple guys, Roger and Josh Tidsbury, were super convivial, and they hosted a very nice session and a very open session for the media community in Cupertino back in October. So I'm very positive about that. I think it's up to Apple what they do, but they certainly see the benefits of CMCD. Okay,
so keep thumbs crossed. So we covered the question which players do support CMCD, so we can skip that question. So, and very important, how do you compare to use CMCD in a multi-CDN environment? That's really interesting because you get so many different logs, and so CMCD promises to be a standard that you could pull from all the logs from all the different CDNs. So how do you see multi-CDN setup with CMCD in the wild? So I don't know, Brandon, Will, if you want to comment, or Igor.
Well, yeah, you basically collect logs from all the CDNs that you're distributing through, and you're going to do that anyway, right? If you're in a multi-city environment, you're getting real-time log feeds from all your CDNs. So if you look at Paramount, they're the case study in this, and I think they've given talks at Mile High Video last year and at Demuxed. They do exactly that. They gather logs from their CDNs in real time, and they get CMCD data from the player in real time. So as you do content steering and you start switching between CDNs, you can keep your session ID, for example, and then track it across CDNs, or you might switch it, and it's up to you as to when you change it. But I think CMCD excels in a multi-CDN environment. There's nothing that says it can't, and it can provide added value and definition in what is otherwise a mass of log lines by the time you correlate them all.
And so typically you would use just the query string version. So in the wild, this is the one that you observe most, or?
No, not true. Roku by default uses headers, right? Headers are cleaner. It really depends. Web-based clients typically use QueryArg, because if you use a header, you have to get an options request before every time you use a custom header. So web-based players almost universally use QueryArgs, but if you're using a native player like Exaplayer, I would use headers.
Okay, but then you would have to ask your CDN to support moving
as I
that into the log.
earlier, the CDN needs to be doing a good job of extracting CMCD from the headers and putting it into their real-time logs. If they're not doing that, then yes, you're forced to use QueryArgs because that's the lowest common denominator.
Okay, yeah, thanks. So what kind of data can you measure with CMCD? We already covered that. And if existing players report back statistics like Bitmovin, is that a solution to a problem that doesn't really exist? We covered that as well. No, it's not. It's something in addition that you can see there. So I'd like to come to the next question with, do we support progressive download? So the plain answer is not really, or not from the sender's perspective.
With a caveat, right? So can you use CMCD with a progressive download? Yes, you're going to make one GET request. You could put a session ID on that. You could put a stream type of other. You can put a buffer length on there as well. You could put all of those and you can use it, right? But CMCD it's got a lot of other features that make sense for adaptive segmented playback. So it doesn't mean you can't use it with progressive download for session identification. It does mean that it's not the best fit because a lot of the features don't apply in a progressive download playback scenario.
Mm-hmm. Okay, good. So I think we can cover one more question. Let's skip here. I think let's skip the buffering. We talked about that. I'd like to go to the third one. So how does one efficiently handle CMCD data at scale? That's something, Brandon, that you did talk about as well. Because if you have the whole data set, then you really need a system that scales well. We have made some good experience with using hydraulics in the backend for this. So any other suggestions about that or experience that you could share?
Well, only on the large scale one. So far, hydraulics is the only one that I've actually seen that can manage, and we're talking at a sample rate of 20-25%. So only a quarter of the logs, and that's been the only one we've seen. I would definitely steer away from cloud tools. They're just not going to do it. So you're probably going to, if you're large. If you're a small player that's just someone with a couple of channels, then you could use a cloud solution. You know, you can use Datadog. Datadog is pretty good, and Splunk and all those. But for scale, so far, I've only seen hydraulics, and hydraulics actually uses ClickHouse underneath. And I know one of the big players uses just their own ClickHouse version, but that's hard work to do it yourself. But yeah, hydraulics is good.
Okay, great. Then, yeah, thanks for all your answers. Thanks for your time being here. Thanks for the audience for coming to this webinar. I found this really interesting. I hope we can do this again at one point in time. Have a great day, everybody. It's good to see you. And yeah, cheers. Stay safe.
Thank you.
Goodbye.
Bye-bye.
Thank you. Bye.